Welcome to all on Sethi. In today's session, I will discuss magnetic effects of current. And this topic is being discussed. Conversion of galvanometer into voltmeter, conversion of galvanometer to ammeter, current and voltage sensitivity and their effects. All these are being discussed through illustrations. Right, let's start. All these are applicable for CBSE board, state board, JEE Mains, NEET, CUET and other entrance examination 2025. Let's start. Question is, a galvanometer shows full scale deflection IG. Resistance R is required to convert into voltmeter range 0 to and resistance R2 to convert to voltmeter range 2. Find the resistance of the galvanometer. To find resistance of galvanometer. In this case, galvanometer is being converted to voltmeter. To convert galvanometer to voltmeter, we have to connect very high resistance in series of the galvanometer. So this point is A, this point is B. In this case, we can allow the current IG. We have to measure the voltage here, B. Now, there are two cases. According to question, case 1, it is a series combination. V will be equal to IG into R equivalent. R equivalent होगा IG R plus G, where G is the galvanometer resistance. Resistance of galvanometer G. This is question 1. In the second case, they are given. This is question range 2. This is R. This will be now R1, IG, R2 plus G. This is equation 2. Now, this figure shows to convert galvanometer to ammeter, we have to connect a very high resistance in series with the galvanometer. Ideally, it should be infinite. Right? Now, voltage across this VAB will be equal to IG into R equivalent. R equivalent is IG G plus R. There are two cases. In the case 1, we have to put this kind of find the range 0 to V, so this is V. When 0 to V, then this will be 2 to IG. Now, these are the two equations available. Dividing 1 divided by 2, we get 1 by 2 equal to R1 plus G, R2 plus G. On simplification, R2 plus G equal to twice R1 plus twice G. So G comes out to be R2 minus 2R1. R2 minus 2R1, that is answer. What is the requirement of the question? A galvanometer shows full scale deflection of current IG. Resistance R1 is connected. Means first case is, this is galvanometer, resistance R1, this is voltage is V. In the second case, this is a galvanometer, resistance R2, voltage is 2V. Apply this concept, right? Now we get, this is the answer. Generally, voltmeter is connected in parallel. Range can be increased or decreased by connecting the resistance. If the voltmeter is to be increased n times its original range, the value of series resistance should be G into n minus 1. By using this concept, we can find out that, right? Now, next question. A galvanometer, if a galvanometer of resistance, this is off. A galvanometer of resistance 100 ohm is converted to ammeter of range 0 to. Given is galvanometer resistance 100 ohm. Using the resistance, shunt resistance given 0.1 ohm. Range is I, we have to measure 1 ampere. Ammeter will show full scale difference for current about. Now, what is the procedure to convert? A galvanometer can be converted into a meter by using a shunt. What is shunt? Shunt is a resistance connected in parallel of the galvanometer. Its value should be very, very small, right? In this case, here I current will flow. Galvanometer cannot allow more than Ig. In this case, apply the KCL, I minus Ig. This point is A, this point is B, this point is C, this point is D. This is shunt. This is parallel to this. So VAB will be equal to VCD. VAB will be Ig into G equal to I minus Ig into I minus Ig into S. Right? Now this G is given, S is given, I is given. We have to find out Ig on substituting and on calculating. We get Ig approximately equal to 1001 milli. We get 1 milliampere approximately. We get 1 millimeter approximately. So B option is the correct. How to convert galvanometer into a meter? A shunt is a parallel resistance connected in the galvanometer. Value should be very, very small. This is the current, maximum current we can allow here. So I, in the galvanometer we cannot allow more than Ig. The balance current will flow I minus Ig in the shunt. Now using the parallel combination concept, VAB equal to VCD, voltage across this will be equal to voltage across this. At this point we use the KCL. I has been divided two parts, Ig here, I minus Ig here. Now substituting we get 1 milliampere, right? Next, regarding shunt, it is used to protect galvanometer from strong currents to increase the range of ammeter. Or ammeter is connected in series, range of ammeter can be increased, cannot be decreased, be careful, right? Now, if the ammeter range is to be increased n times original range, the value of shunt resistance should be G upon n minus 1. By using this formula, we can find it answer, right? Now, next question. The current sensitivity moving coil current increases by 20%. Let initial current sensitivity is IS1. Then IS2 will be equal to IS1 plus increases by 20%. 20 by 100 IS1. This comes out to be 1.20 IS1 finally. Similarly, voltage sensitivity VS1 initially is IS1 over R. R1, this is equation. Now calculate the by VS2. VS2 will be equal to IS2 upon 2R. IS2 क्या हुआ? IS2 is 1.2 IS upon 2R. We take it, so 3 by 5, this can be written as VS1. This can be written as VS1. Now we have to find the percentage decrease. Now as percentage decrease of any quantity is equal to find initial minus final upon initial into 100. That is the answer. Initial is VS1 minus 3 by 5 VS1 upon upon this will become Bs1. So this comes out to be multiplied by 100. 1 minus 3 by 5 into 100 to 40%. So decrease will be 40%. The current sensitivity of moving coil gap will increase by 20. When its resistance is decreased by 2 factor, calculate by what factor does the voltage sensitivity. Now we know current sensitivity increases by 20%. So this will become of 1.20 of initial. What is the voltage sensitivity? That is the current sensitivity divided by the resistance. So initially is this, finally is this, right? We get it like this. Now percentage decrease, this comes out to be like this, right? Next question. Now I will start. Next question, describe briefly how the current sensitivity of a moving coil galvanometer can be increased. Current sensitivity equal to what? Deflection per unit current. In the galvanometer is particularly on deflecting torque equal to deflecting torque equal to the restoring torque NIBA equal to K theta. Using this thing, theta upon I will be equal to NBA upon K. These are the factors on which current sensitivity depends. This can be increased by using number of turns of the coil. Can be increased by increasing number of turns of increasing the magnetic field strength applied, increasing area of cross section of the coil. Okay. In this phosphor bronze strip is used material using of lower torsional constant. These are the factors on which current sensitivity depends, and if we want to increase, number of turns should be increased, magnetic field strength applied to the area of cross section K should be decreased, right? Next question. A charged particles is moving in the circle path with a velocity v in a uniform magnetic field. If the velocity of charged particle is doubled, the strength of magnetic field is half, then its radius becomes. We know when charged particles enters in uniform magnetic field, perpendicular to the direction of field, it is moving that case QVB. Centripetal force will be provided by the magnetic force. This goes this, so MV comes out to be QBR. Now according to question, charged particle means same charged particle. This is same. What is changing? This is changing. We have to find this. These are the changes. Which are same, that has to be taken into constant proportionality. Then V1 over V2 will be equal to B1 over B2 into R1 over R2. Now according to question, substituting the values, velocity is charged particle doubled. So doubled means this is V, so this will become 2V. This is V, this becomes 2V, equal to magnetic field is reduced to half, V divided by 1 by V into R1 over R2. So this becomes 1 by 2 equal to 2 R1 over R2. R1 over R2 will be equal to 1 by 4. R1 over R2 will be equal to 1 by 4. R2 will become 4R1. R2 will become, means radius will become 4 times. What was the requirement? The B option is the correct option here, right? Again repeating, centripetal force is provided with the magnetic force QVB. Now check what is given in the question. In the given question is the charge particle is same, means we have to consider mass of the charge particle is same, Q as same. Variables are velocity and magnetic field and radius, right? Now which are constant, that should be taken to constant proportion, make the ratios. After making the ratio, substituting the values, we get the final answer. Next, proton alpha particle enter uniform magnet perpendicular to the same speed, same as mv square, as discussed above. Mv square r equal to qvb. Mv equal to qbr, right? In this case, particles are changed. Charged particles are different. Using this is same with same speed. This is same. Changing is mass Q and R. Changing are mass Q and R. Make the ratios M1 over M2 equal to Q1 over Q2 into R1 over R2. In this case, indirectly answer will be found. Alpha particle, so 1 by 4, right? This will become 1 by 2. Proton alpha into R1 over R2. R1 upon R2 comes out to be 1 by 2. This is not the answer. We have to find the ratio of time periods. To find the time period, we use T equal to distance of, speed equal to distance upon time. So time will be distance upon speed. In this case, 2 pi r upon v. So Tp over T alpha will be equal to, this is same. So this will be equal to R1 over R2. This is given to 1 by 2. 1 by 2 is the answer. Let's see what is the answer. A is the correct option. A is correct option. A is correct option. Right? In this case, again repeating, write the formula and according to the question, see which are given, which are constant, which are variable. Which are constant, that will be taken to constant proportion, make the ratios. After put the values, we find the final answer. In this case, we are not getting the final answer. In this case, we first find the ratio of radius. Now we know we have to find the time period. To find the time period, we use the formula speed equal to distance upon time. In one cycle, in one complete circle, 2 pi r distance will be equal to velocity. Velocity is constant, the Tp or T2 will be proportional to the R1 over R2. That comes out to 1 by 2. Now I will like to request, if you are new to my YouTube channel, Sethi should learn and like this video, please subscribe and share the channel, press bell icon to receive updates on concept clearing videos on. Thank you. धन्यवाद. बहुत बहुत धन्यवाद.